because Zach Labe talked about the important figure graph shows global climate variability bumps and climate change long-term upward trend. The 12-month running mean is about 1.3 Celsius above pre-industrial level. And then it shows the global surface temperature relative to 1880 to 1920 mean. So I'm transitioning, yeah, it's to help, we're at that 1.3, NOAA says 1.1, okay, but we're getting to 1 degree Celsius. And what, 1.5 is the Paris Agreement? It's, we're like right there. And there's no uproar about that, right? We're just in America trying to get, well, not us, but Joe Biden elected to get into the Paris Climate Agreement again. But that doesn't even remotely cover what we're talking about, 9 degrees C, 5 degrees C. Limiting to 1.5 is nearly impossible. A 2 degrees Celsius, we're throwing that out the window, but
Oh, I argue this a lot in many of my video segments. I basically said, even if we were to stop, at this very instant, no more, fossil fuel emissions, there's so much thermal inertia in the system, we're going to blow past 1.5, if not 2.
right.
1.5 definitely within a decade of 2 degrees by, 2035, 2040, at the latest, really.
Exactly.
Think about it. I mean, it's just, yeah, it's kind of tooting away on us.
And what we're talking about, it was the fact that our temperature variability could increase. It could accelerate by 2100. We have this 2 years ago, right? It was the IPCC report. Maybe they said 3 to 5 degrees Celsius, but now there's studies coming out that it could be 9. So once again, we are accelerating based on what's happening with examples like Siberia and what's going on in the Arctic. There's so many feedback loops, and then the ocean's warming. There's so much to cover, but it's just acceleration is the key word with our global average temperature.
I just did a video segment with some new estimates for sea level rises, and it's like basically, the estimates have been an underestimate, and now they're realizing that the sea level rises might increase exponentially. Well, it makes sense, because if we're now saying the temperature increases are going to be exponentially, that means what? The glacial melt will increase exponentially. And since if you're melting the glaciers exponentially, and the glaciers go where? The melt goes into the oceans. So we expect the oceans to also follow a similar pattern. And then you add on top of that, you're heating up the oceans. Right? We've seen the graphs of the sea surface temperatures. You're going to have thermal expansion on top of that.
And I wanted to sneak in a quick story. I can just read it. It's just very quick. And it relates to what you just said about the glaciers. It says New Zealand glacier, this is from ecowatch.com, has lost enough ice to provide country drinking water for 3 years. And essentially, I thought of you because, the scientists say the Brewster Glacier on the South Island lost 13 million cubic meters of ice between 2016 and 2019. The National Institute of Water and Atmospheric Research said. So yeah, glaciers real time are melting, and then that raises the sea level.
Yeah.
So
especially given the proximity of New Zealand is to the ocean. Yeah. But also there's the other aspect that, most people rely on the snowpack from the previous winter of melting out slowly to provide irrigation, water, drinking water, that kind of stuff, And now if it's quickly melting away and gushing away on you, you're going to lose that reliable source.
Exactly. And I think it's like 2% of the earth is actual drinking water, fresh water. So there's not much, and if that shrinks, that's not good for us. And glaciers provide a lot of that. And it's all over the globe, right? It's India, like the Himalayas, like these glaciers that provide water resources are disappearing. I mean, that's just a recipe for like a Mad Max movie. I know we say that, but it's like a water world.
It is a major concern. In fact, the Himalayas are often called the third pole.
Okay.
For when it comes to like ice and that kind of stuff. It is a major concern. But here's another interesting little thing to think about. I've got a video that I just recorded and edited, whatever. But another thing that is at risk is groundwater.
Mm.
And there's more groundwater than there's water in the Great Lakes, for example, planet-wide. And in fact, so and what's happening with depleting the groundwater? Well, also because with depleting it, a lot of the ground is sinking. You pull the water out, and the ground sinks into where there was water to keep things buoyant. But where you're pulling the water out, and it was remaining there because you're changing the physics and you start introducing, especially if it's a region near, you know, the ocean, you start getting brine injection. So then you start increasing the salinity of that groundwater. Now you take a place like the Oglala Reservoir, which is under the Great Plains, we just about suck that damn thing dry.
Right.
And and so now what's happening is they're pulling up brine water. Well, the plants don't like that salty stuff. You're going to start killing the plants.
Oh yeah, and then the drought issue, right? Does that contribute?
And the drought contributes to that. Yeah, absolutely. So, so we're sucking the groundwater dry, which provides, aquifers, wells and then irrigation and, and whatever water remains, in a lot of cases, it's getting saltier, which is not good for drinking or consumption or for raising crops.